short on time. Everyone, please, Charles Moore.
Dance out here and kick up my heels. Will you use it? Yes. First thing I want to put on there is the most exciting. I asked a question on ColorForth as to what I should talk about today. And I got yes, I got a reaction. I will talk about maybe 10% of it. It had to agree with what I was already going to say, you see. Partly it did. But I invite you the same. Anything you want me to talk about, I will stop early enough that less than trivial questions can be asked. To answer one question, ITV is alive and well. Things look very promising. Who can say what that will happen next week, but we're working at it. I am not permitted to say more than that, except that an amusing aside. We had a due diligence review from a Silicon Valley technical expert. I was looking forward to this because I wanted to see what a real authority could say about what we were doing. It was disastrous, absolutely disastrous. I think the kindest word he said was aesthetically elegant, but the harshest word was anachronistic. And in a sense, he's accurate, but
That was a negative term.
Silicon Valley is not looking forward to products we are making.
So who was this person?
I ought to say that. He is a respected authority. I would welcome a chance to debate him sometime, but that won't happen.
Here's a report about the company.
No. From the board. Here's an interesting picture. We're talking to a new fab. We've burned through two fabs. I don't know if you know this, but HP 0.8 micron is gone, and that's what I was using for the last 3 years or something. We ported to a 0.6 micron LG process last year, and the LG is gone. So we're shopping. This fab had a lot of different processes, so I had a chance to make this picture. On the right, you see the feature size from 0.2 to 1 micron. And vertically is the number of microamps of current per micrometer of transistor width. So this is the current through a transistor. And roughly speaking, the speed of a process is going to be proportional to the current through a transistor. That's about the only variable left. Now here we are at 0.8 micron, about 500. And that just happens to be MIPS too, which is convenient. If we were at 1, we would be slower. If we were at 0.5 or 0.6, we would be faster, but not by a whole lot. This is 5 volts. This is 3 volts, in red. And at 0.6, when you go to 3 volts, you slow way down because you aren't going to get as much current. 0.6, then this is 0.35. I guess this is 0.5. And I plotted it off scale because I had to make the line look linear. It's interesting that it's roughly linear. That the smaller the geometry, the faster it will run. This is an IBM process up here at 0.2 and 1.5 volts. And that to me is enormously impressive. Given that these are the marginal gains you get at 3 volts, to get way up there at 1.5. I'd like to work with that process. But that's only a factor of 2 in speed from where we are now, which is a little bit disappointing. I think maybe it's more than that. It's maybe 2.5 or 3. Can't know until you try. These, we're going to be 50% faster than we are now, but not a factor of 2. And there's a fairly considerable cost to going to smaller geometries in cost, dollars. The smaller geometries cost you more than the larger ones. That is why we've been sitting at 0.8 for so long, because it was a nice, comfortable, mature process, low-cost fabrication. We can't sit there and this is obsolete. We're going to have to move to here. No particular reason to move to there unless we run out of speed. One of the criticisms of our process was that we were claiming these ridiculous speeds. When everybody in the world has agreed on dry stone MIPS as the proper measure of processor speed. Now, am I wrong in saying the dry stone MIPS measures seat compiler performance? Yep. It has nothing to do with processing. That was a weird comment to make. These speeds are, I think, honest. I've been telling you for years, this is burst rate for a series of 4 instructions, and we have to wait for memory access. Well, I spent some time designing an SDRAM interface. SDRAM will give me 10 nanosecond access to a significant amount of memory. Something that's long overdue. And I got to redesign the memory manager and the interface to the processor and coprocessors to take advantage of that. But when I do, and that's another month's work, it's funded, I'll have a sustained 500 MIPS. If we were to go to 0.35, I would have a burst 600 MIPS, but I probably couldn't sustain it. Certainly I can't sustain the 1,000 MIPS. Simply because memory is not fast enough anymore. If I get 4 instructions per word, you take whatever your memory access rate is, divide it by 4, and that's the clock speed that you can reasonably sustain. I've always felt comfortable in having clock speed 2-3 times as fast as I needed, figuring there'd be something useful to do with it. SDRAM may do that. All right. Let's go on to what people really want to hear about. This was one of the most popular questions. ANS4th is an increasingly significant fact of life in the world as we know it. It may not be to my taste, but it is to lots of people, and I've no quarrel with it. What is it I don't like about ANS4th? Well, Skip showed you a whole list of people working on ANS4th, and I figure I don't need to do one more of them, so I can do something different. And that's really what I want to do. I just want to try something that no one else is exploring. But if I were to use ANS4th, or try to become compatible with it, I've got some objections. One is basically the concept of a standards document. If you read the document, it gives you the impression that Forth is more complicated than it is. Or else it corrects my misinterpretation of how complicated Forth is. This goes back to, I like to quote Gödel on this back in 1930. He proved that a self-contained formal system cannot be complete. It's horribly non-sequitur. All right. Within the system, you can't describe itself completely. Within Forth, you can't describe Forth. Well, I mean, our systems are not so esoteric as Gödel's, but I think you can say that within a system, you cannot describe describe itself simply. Now, the standard is not inside Forth. The standard is outside Forth. It's looking at Forth and trying to describe it from a meta standpoint. But even so, when you have to explain what every term means accurately, like what is a cell, what is an address unit, what is a character, and how does it fit in with all those other things, it gets ominously complex. Particularly so since we all know what it means anyway. And it's an exercise in precise writing rather than an effort to convey meaning. So I object to that aspect of the standard. There's nothing you can do about it, except that I'm rewriting the standard to suit my taste, and it will be much simpler, and I hope convey much of the same information, and some way that will be available. Another thing I don't like is that the internals are exposed. There's far too much discussion of words that an application programmer will never use. Particularly if that application programmer doesn't decide to write his own interpreter. And I really don't like people writing their own interpreters, because that means I have, as a user, I would have to learn a different interpreter. When Forth has a perfectly good interpreter, if you will only accept the word order instructions. So words like word, state, and hold, and another dozen or two, not that they shouldn't be in the standard, they shouldn't be in the core word set, they should be de-emphasized by the standard, or there should be another standard appropriate for application programmers as this one is for system programmers. And then the double words. Get rid of all the double words. We don't need to do 64-bit arithmetic. The machines now are 32 bits, or at least 20 bits. And in no case are double precision arithmetic relevant. And it complexifies things horribly. If you look at these arithmetic operators, /mod or something, I mean, what in God's name does that word do, and why should I care? Well, you should, and it can be gone. U/mod is too complex. Slash, certainly. /, yes. Mod, maybe. But that's about the end of it. And that includes words like 2/, 2swap, 2fetch, 2store. You oughtn't use such words. They make your stack more complicated. They're making presumptions as to the layout of data in memory, which you probably shouldn't be making. It's just too complicated. If you want an extension word set with all these double arithmetic operators, fine. If you want an extension word set with all the internals necessary to write your own interpreter, fine. But not core word set. Good things about the standard are, yes, it adds credibility. A lot of people will consider Forth that wouldn't have considered it without the ISO standard. So, good thing. Another thing it does, it focuses our attention as a community upon issues. Instead of arguing about what Forth is, you can argue about what postpone means. And that at least is talking about something that has some hope of resolution or conveys some meaningful debate among the community. So I like those aspects of the standard. If the standard didn't exist, I couldn't be here bitching about it. So
I do like 2fetch and 2store because I can handle access coordinates in one fill street that way.
well, then you should call them vfetch and vstore, and they should be an extension. Yes, not that these words are not useful or necessary or nice, but standard. The standard is too much common practice, and I think it needs a little more pruning. All right, here are two other Forths, and I would like to argue that they aren't the same. I don't intend ColorForth to be machine Forth, although in a sense it kind of is. And one of the questions about machine Forth had to do with the address register. So I thought I would explain why there is an address register. And yes, it is not very Forth-like. It goes back to Novix days. I don't know if you remember the Novix. I got a email question about it recently, and I didn't remember the Novix either. But when you did a fetch, the problem was the address was on top of the stack where the data had to go. So the address is driving the address lines, and now the data comes in on the data lines, and where do you put it? Well, what the Novix did was it put it underneath the top of the stack. And then it threw away the address on top of the stack. Optionally, if you're doing an incrementing fetch, it put it underneath the top of the stack and incremented the address which was on top of the stack, and everybody was happy. But implementing that in silicon is a mess. You've got address lines going in the wrong place, the second element of the stack, or data lines going in the wrong place. You've got address lines coming to the top of the stack, which is equally inconvenient. You need a second cycle to fix up the stack after the operation is complete, which is ugly. To eliminate that, it made sense to move the address to a special place out of the way, and then you clear up the stack to receive the data. Now, this really wasn't my idea. This was Russell Fish's idea in Shiboda. And I have a lot of quarrels with Russell Fish, but he did have some good ideas, and I appreciate it. So, given that the address register was kind of the least inconvenient way of handling addresses, I kept it for the P21 family. It does let you do fetch plus and store plus. It makes it easy to do, almost free. I would like to recommend that you use those words in your forth. It's easy to define a fetch plus. If you do, you'll find it has a significant effect upon your programming style. You're keeping an address off stack. It offers the most efficient I know of addressing mechanism for sequential access. The alternative is something like do loop with IX fetch inside it, which is a very expensive sequence of words. That's a hard way of doing something equivalent to adding one to the address every time through the loop. This is much more efficient. I'd like to see it moved into the standard. Not so much that, well, to supersede some of these old-fashioned, slow ways of doing things. The standard is documenting forth as it was 20 years ago. Hey, let's move a little faster now. And then with SDRAM, this kind of fetch plus becomes even more important as an efficient way of getting at memory. Sequential accesses for, everyone knows SDRAM, I imagine, but you can get up to 256 sequential accesses at 10 nanosecond intervals. If you break that sequence of fetches, it's going to cost you a 20, 30 nanosecond hit. So sequential accesses are cheap. In the case of the F21, you could do fetch plus, fetch plus, fetch plus, fetch plus in one word, streaming your data onto the stack with no interference from instruction fetches elsewhere. Nice. SDRAM also has two blocks of DRAM. So you can ping pong back and forth without having to read a new page each time. You're still a hit, but it's not as big a hit when you're changing pages. So you can have an instruction page and a data page. And by new interface, we'll optimize that and then make it all visible to users. If you don't know what's happening, you aren't going to be able to take advantage of it. Now, ColorForth. Most of the work I've done on ColorForth is on the PC, because I've never gotten a nice version of any software running on the i21. I've been too busy making the hardware work to worry about software. It's as if I have a threshold or a container of interest, and I fill up my container of I-21 with hardware, and there's nowhere for the software to go except the PC. Nothing I'm doing will have any difficulty porting to the I-21. The fact that the I-21 is 20 bits wide and modern computers are 32 bits wide is totally irrelevant. It is a non-problem. In the case of the software that ITV has developed, I think there's only one or two places where the 32-bitness of TCP/IP was of any concern. 20-bit chip is capable of doing almost anything a 32-bit can. You can even pack two 10-bit bytes in a word if you want to, or three 6-bit bytes. How do I edit in ColorForth? Yes, I do have my own custom editor for doing this. I think everyone should have their own custom editor for editing their program files. I don't believe in universal editors. An editor is so easy to write that why not? A browser is very easy to write too. I know people don't like to believe me, but I will give you some examples in the course of the next year. How do I edit color? Well, I assign function keys. I've got 6 space bars, and I hit the right space bar and I get the right color. I will label the function keys with color dots as soon as I find my little box of color dots. But meanwhile, it's blue, it's green, red, and blue in bits 1, 2, 4. What more can be said? Keyboard entry, command line, same thing. You hit the color space that you want. Now, why is the space before the word? It would make sense that you accept a word, and then the terminating character is the postfix command telling you what to do with that word. And I've thought long and hard about making it work that way. The alternative is to have the space in front of the word, which makes it much easier for an editor or a browser or something to format the word correctly. And that's the way I chose to do it. And it turns out that I was right. Because not only is the space in front of the word important in determining what to do with the word, but the space after the word is also. So this way I have 2 spaces. In fact, there are 3 spaces of relevance. There's the current color, the color for the current word, the preceding delimiter, the next word, and the previous word. I require all 3 of those in order to do the right thing in the interpreter. So it finally came to me that what I've got is a 4x3 stack. I've got a 3-entry stack of 4 bits to describe each of these states. And so I have a little push-down loop in which I multiply the previous value by 16 and add in the next value. And I've got the 3 in one variable in the order in which I need them. And I can peel off the one I want just by shifting. This is much easier than having either named values for each one, named variables for each one, or a little array in memory of individual words storing 4-bit values. So I'm pleased about the invention of the 4-bit stack. Given that I've determined what I'm going to do with the word, I go through a jump table to actually do it. In other words, I know the preceding space, I know the word, I go through a jump table to determine whether I'm going to convert that word as a number, or whether I'm going to look it up in the dictionary, or whether I'm going to throw it away, or whatever. And one of these destinations in the jump table takes me to another jump table where I take the next word, the next color, and go through another jump table to decide what to do with this first word I've got. I'll show you some examples of that. But it's a very efficient process. Much more complicated than the old-fashioned state variable compile or execute. But I would like to propose not a new concept, but certainly a new emphasis to an old concept. I like to call it nice. Nice has a nice cold connotation. And that stands for interpret. Can you guess? Compile. I guess you can execute. And this is what makes Forth different than C. I think this is one of the unique capabilities of Forth. In addition to the two stacks, in addition to the highly factoring, the fact that you can move back and forth in these three behaviors of words is very important and can lead to very compact code of the order of 1% of the kind of code you get if you don't have these three behaviors. So I'd like to give you an example. .bmp. I've always wanted to document the behavior of OCAD, and I've had a lot of difficulty doing that because no matter how many words I write down, it's very helpful if you can look at a picture. So I wanted the ability to transfer portions of the OCAD displays into HTML documents. And I was going to do construct GIF files, and Mark Smeater pointed out that I'd already constructed BMP files. I may as well use those and avoid having to pay the royalty. They aren't as compact, but compact doesn't really matter. So I wrote an application for generating .bmp files, and I will present that to you now. And I hope you're not going to be disappointed. It isn't very hard. This picture probably doesn't show up too well. It's 4 of my 256 byte strings.
You can peel that strip.
Can I peel? Oh, it doesn't. I don't know if it's printed. Maybe print on top. No matter. You'll see together. Here's a bit of ColorForth. First, I'm starting with a 640 by 480 screen full of stuff. And I have a little inverter in the middle of that screen. And I want to convert that inverter to a BMP file. But first I want to throw away all the margins. So that's what this word frame implies. I'm just throwing away the frame of the image. The part I want is the only part of the screen. I apologize because this code does not work for an empty screen. It will crash. But someday I'll fix it, and meanwhile I promise never to try to construct an empty BMP file. Here's empty, throwing away everything else. So what I've got is a minimalist force system underneath here. Essentially, nothing more than machine force is available to me at this point in time. I'm defining some variables. I ended up needing 3, buff, W, and H width, height, and an address pointing to the buffer where I'm constructing the image. The first thing I do is define a word row, colon row, which is going to scan across a row of the image, checking to see if it's empty. And if it is, it returns a 0, apparently. If it falls out of this begin next loop. It uses fetch plus. It isn't very long. It is rather fast. It goes through 159, which is 160 4-byte fetches looking for non-zero, of course, of doing this. So I've taken advantage of the fact that the image is, I forgot one tiny thing. This is a VGA image packed in a horrible way. First I have a little machine language word that goes out and takes this and stores it as bytes. So I've really got a byte image I'm working with here. And that cheat will go away as soon as I get to 256 colors instead of 16. So this is the way it will be. Given the word row, I define the word rows to scan rows until I come to something that's non-zero. And that extends to here. Rows repeats. It's just another loop. These counted loops are a real pain. I don't like counted loops, but in a case like this, that's the way you have to do it. So I've compiled this stuff, then I switch to the interpreter and I reference it. I set H to 448. I call VGA to construct my image, and VGA tells me where to put it, and I call rows to come down from the top until I find something non-zero. I call rows to come up from the bottom until I find something non-zero, and then I go on. Guess what happens next? Find the word call. The word calls do the same thing. Then I switch to interpret, and I use call and calls to bracket the image the other way, and I end up with buff marking the beginning of the image, H containing the height, and W the width. But there's some interesting things happen. First, up here in call, I want to know the width of the row that I'm going to have to examine. And I want to know the height of the column that I've got to examine. And that's stored in H. So I fetch the value of H and I subtract 1 from it and I pass that as the controlling argument for my begin next loop. And this is executed at compile time because it's black. And when it switches from black to green, it's compiled as a literal. So this is an expression which is evaluated. Here's an example of buff. Now buff is a variable, but a black buff is executed at compile time. So here I'm getting an inline literal representing the address of my buffer, instead of a subroutine call to the code for variables. And this is faster, a little bit bigger. And here again, in calls, I want to subtract 1 from the width. -1 W plus 4. -1 is a literal. This reference to W is white, is black. So it gets executed at compile time as an inline literal. Again, just like buff. Unfortunately, there's a little problem here. If this -1 had a white space following it, then it would be left on the stack. And I don't want it to be left on the stack. I want it to be compiled as a literal. So this is a green space here. And then there's a white space to be the prefix for W. And that's a little bit obscure on the listing. But if you move a cursor through here, you will see the cursor change colors and you'll know that it's all right. And this is
secret decoder.
I was thinking of that. We need a secret decoder ring. Okay, so there's the code for framing the images I'm after. Now here's what we're going to do with the BMP file. Here's the nice blue BMP and all the nice hex digits. This is the boilerplate necessary to build up the header for the BMP file. I've redefined the word comma to put down 32-bit constants as they want. Then I use a comma also to put down 32-bit color lookup table appropriate for this image. And it slopped over into the next screen. Then lo and behold, I define the word row in rows again to go scan the image and put out the pixels. And I've defined the word pack to pack the data 2 pixels per byte as in the inverted order that they wanted. And then finally, I reference the word rows, and I'm done. I've got the file in the buffer. I know where the buffer is. I can go back to DOS and do run a little program that writes it out to disk. I would argue that these 2 screens, which is really all that's involved with BMP, is a pretty small amount of code to write a BMP file. The equivalent C in the supercharged bit graphics that I looked at that told me how to do this was 2 pages of C, I guess. And of course that was lots of comments, and I don't have very many comments. I do have BMP at the top though. It counts. I also make the claim that given any application you want, I can write code about this size that will do it. If I want an editor, I will have an editor in whatever, a handful of these screens. If you want a protocol stack, okay, I'll do some more. There are some considerations. I don't have all this stuff compiled in memory at the same time. I don't have a system which does everything. All I have is enough code to generate the code that I need. I would do this with any application. I used to do this at ForThink. If you wanted to produce a report from your database, you compiled the code that generated the report at the time you requested the report. It didn't take any time. It didn't require any name conflict resolution. It gave you a small, self-contained description of the report. It was a very efficient way of writing software, and I think that's gotten lost in these mega support systems. They've lost the ability to compile at runtime. All you can do is execute. They've lost the ability to do some things in interpret mode in the course of compiling. Interpreting is more efficient than executing. In order to compile anything, you have to interpret it first. If you've interpreted it, you may as well execute it and be done with it, instead of putting it down and coming back and looking at it again at execute time. The side effect of doing this is that you end up with a system that consists of a large number of small applications instead of a large system with all of the applications somehow embedded in it. I think that's the cause of a lot of trouble. It goes back to the comments I made about the standard. The standard has everything built into the core word set. If it were factored a little bit better, it would be easier to understand and provide more versatility. I have a list of more questions that people have asked, but let me ask you for questions first before I go into those. Am I not prepared?
You said you
can't talk about where you're working, which is the other question. Which is sensible, I would do.
Now, the negotiations are delicately proceeding. One consequence is that we have not had the funding to make any chips for the last 4 or 5 months, so there haven't been any chips made. I have done some work, I have added features, I've came up with a whole new chip that's sort of the best of all chips. But at the moment, I don't know if that chip is relevant, and I don't know what other chips might be relevant, and I'm sure someone's going to come to me one day and say, this is what we want. And my reaction will be, but this is completely different than anything you've ever said. So I'm kind of waiting. I'm in a document mode. I've got some very pretty 8 HTML screen with gates and showing off the various kinds of gates that the system uses. But there's a bug in it. I can display this fine with IE, but my color inkjet printer won't print it with the right colors. I mean, I showed you the color table there. Those are the colors, and I know they're right because they're displayed on the screen, but the printer won't print them that way. And I don't even know who's responsible for putting out the colors. Is it the printer driver, or is it Windows? But someone that's dropping the ball. So I'll show you that sometime, or it'll be on a website sometime. But it is very pretty. And it is much easier to understand silicon design when you can see it instead of when you have to read the net list. We are still at our old site, the second site on Fifth Avenue, Redwood City.
UNC and the TSMC are now fighting for customers. And UNC actually put out a very nice program, which they call a shuttle program. And they actually, for customers who want to try their chips, their new designs, they'll do it for free. And they run the fab every month.
That sounds to me very attractive. I mentioned it to Gary Langford.
Mm-hmm.
And he says that the TSMC, I think he was the one he was referring to, has a very active legal department defending themselves against intellectual property claims. He doesn't want to go there. He's afraid of losing whatever proprietariness we might have in our design. I'm more sanguine about this is an invulnerable design, you cannot replicate it without the design tools. But he doesn't want to bet the company on that. If that it turns out to be the only alternative, that's the way we'll go.
It looks like these two companies are probably the foundry of the future.
We're talking to some Israelis.
Mm-hmm.
Now, the Israelis are not known for honoring intellectual property either. So I don't understand the distinction he's making.
Mm-hmm.
These kind of choices tend not to be economic but political. If we're dealing with a company that's dealing with a company that knows somebody in Israel, that's where we'll go. I mean, we have not had our free choice. I've never had a free choice of foundries. It was First Orbit. They're the only ones that I knew about, and they were cheap. And it was Moses with HP. Now Moses has 3 or 4 others that we could pick. But it's $5,000-$10,000 shot, and without the money, you can pay somebody for a month for what it costs to do a cabinet. That's what we're doing.
Have you found any way to look at the chip design through in OCAD in any kind of hierarchical fashion? At any time to take a look at that after discussion in the last year?
No.
What do you mean by hierarchy?
The chip layout is flat. All the latches are laid out in the registers. And there's no way I can change the layout of a latch and have it propagated everywhere there's latches. But I'm not strongly motivated to do that. It might have been a better way to start, but it is very important that I have the flat layout in order for the simulator to be able to simulate it. So I have to flatten everything anyway. Given it's already flat, to make it hierarchical is more work, not less. There's a number of changes I want to make to OCAD, but it isn't clear there's ever going to be a convenient time to do that. You start down the path and you pass the branch points, and where do you end? More important, I'd like to get John has suggested changing the tiles from being 16 different patterns of corners and crosses and things to about 4 different patterns of straight lines and that meet and bends.
Right.
And that's higher on my list than the hierarchy.
Another thing is that, recently Xilinx is collaborating with UMC and then on their milling gate FPGAs. And Pura is teamed up with TSMC in their milling gate FPGAs. It looks like to try out things instead of going into the fabs. It would be much easier to just grab one of these chips and then just throw your design on there. At least you have something that runs a tenth of the design speed, but you can get the chips.
Might as well, for that you can just use the software simulator, because the only thing that would give you in this environment thing is the logical correctness. It won't give you any other information.
But the timing would be completely different.
Yeah.
Yes.
And some of the trade-offs would be different. And if I were just starting out, I think that would be a very interesting path to follow. Things get complicated. But given where I am now, I don't need any practice. I've got a simulator which I'm convinced now tells me true. And if nobody wants to make production quantities of these chips, I've got other things to do. I'm not gonna beat a dead horse. My goal at the moment is not to design another chip, but to sell some chips. And selling some chips means you start at $1 million. If you're not doing $1 million, it's not worth doing. The economics of the industry have changed in the last 10 years to more and more reliance upon large production runs. And you get great concessions from the fabricators if they anticipate a large production run. And no one is interested in 10,000, 20,000 parts. It's just not worth anyone's trouble, designing or manufacturing. So you've got to, if you're going for the small, if you want 100 parts, yeah, FPGA is going to be the way to go. But there's still a big gap between 100 parts and 10,000 parts. It's completely empty.
What are you going to do with ColorForth?
I expect I will publish it on a website somewhere sometime, as soon as I get it to where I like it. It'll be very small. K, 2K, something like that. Boot from floppy or boot from CD-ROM. If you give me your hard disk, I'll put it on your hard disk. But I doubt I could live with a partition. Probably have to do the whole disk. Which is why I say, here's a whole opportunity for discarded computers to come back to life. Good question. Here, what would I do if I was rich? It wasn't phrased quite that way. It's what would I do if I didn't have to work for a living? And I do exactly what I'm doing now. I'm very happy with this. I wish we could get into production. If we get into production, there's a disturbing consequence. If we put a chip in production, it'll be the chip we used last year. It won't be my newest best chip because it has no history. It's chicken egg. How can you prove the value of the new chip when nobody will let you make one because they're busy making the old chip? You know it doesn't work. And with large production, with the pressures of production, I think a huge amount of innovation is going to get lost. This is a conundrum, but even so, I'm tired of innovating. I'd like to get some production. ColorForth looks to me to be a lot of fun. I will try to readdress these issues of my wild, irresponsible claims as to how small software can be. But I will repeat them lest anyone misunderstand. I do not think it is intrinsic in the nature of software that it has to be large, bulky, buggy. It is in the nature of our society. We now have millions of programmers who are relying upon their paychecks, and they've got to keep busy. Y2K is a boon for the software industry. You can drag old retired programmers back and put them to work. There's so much economic motivation to producing this bloatware that I kind of feel irresponsible in standing up and saying it emperor has no clothes. But at least in my small way, I will accumulate a library of examples to prove the point to anyone's reasonable satisfaction. I don't expect it will sweep the industry. There is one way it could, and that is if a small group of people got together and decided to challenge Microsoft. We could replicate their software in 0.1% the code. We could feasibly do that with a small team in a year or two. But again, why destroy an industry? That's probably not a wise thing to do.
No, I don't think you could do that. Because to do it effectively, you would have to replicate their bugs.
Oh no, I'm not running applications.
Oh, okay.
I'm replacing a whole schmear, a whole industry.
Oh, yeah, you can do that.
That's much more practical.
You have to find the bug before you replicate it.
Well, the Chinese is doing that. And they are very much worried about Microsoft controlling every aspect of the industry. And so they are actively building up their own OS. And they just don't want everybody to use Microsoft.
You said the evil word. If they're starting for an OS, they've made the first mistake. And the OS isn't going to fit on a floppy disk and boot in 10 seconds. Actually, the greatest problem to having a fourth come up nicely with the picture on the screen before you can blink is the damn BIOS. If it powers up in BIOS, it doesn't power up on the floppy, and it takes you 10 seconds to get to the floppy. So you've got this built-in delay, which is useful. But I'll give you the problems that you can plug in the sockets if you want to do that. None of this is hard. There was a book. It was translated from the Danish, written about 1989. I can't remember all of it, sorry, but the title was The User Illusion. It should ring a bell with everyone, because the user illusion is what Apple exploited. To make the computer look different than it really is, to make it friendly and easy to use. So the user has an illusion that he's dealing with the software, when really he's dealing with the hardware. And he viewed this as a good thing. Among many of his good comments, this was a misunderstanding, I think. I would like to dispel the user illusion and make the interface transparent and get back to the hardware. Of course, that's what Forth is good at. I repeat the claim I made long ago. It is easier to write a floppy disk driver in machine language than it is to write it, the interface to the BIOS routines that read the floppy disk. And that's true of every device. All the devices together, that's a different problem, but you aren't dealing with all the devices together. I'm not going to give you every printer driver. I'm going to give you the HP inkjet printer driver. And if you want a different one, you have the knowledge and tools to build one.
It doesn't work.
Well, some of these mechanical things are even cheaper.
So is ColorForth going to have the same colors as the iMac?
All those colors?
I've been thinking, we need, Compline Forth was talking about Forth logo. I don't know how many of you follow that, but the logo was sort of voted down. It was an anime Jedi warrior girl, scantily clad. But that got me thinking, what we need is a Forth uniform. How much more impressive it would be for me to stand up here looking at you if you all had your cadet uniforms on. In that regard, I think it's pretty clear that the uniform should be that butternut color that monitors are made of, so that you would blend in with your computer system. But you could have white piping on the ANSI Forth programmers and red and green piping on the ColorForth programmers. So you could tell at a glance the essential information about your audience and their level of sophistication.
You're going to have a special program, and you're going to have dancing color.
Yeah. Oh, and these would be compatible with ColorForth. And now,
The Big Forth programmers have silver and gray piping.
I wore this T-shirt trying to get into the uniform mood. I noted a dearth of T-shirts. Is anyone selling Forth T-shirts?
You're the second to ask.
Is there a whole opportunity here for marketing?
In fact, what's the score on the inventory? I'm not really on the inventory, but trade person. One of us came to me and asked, hey, I got a design. So there's design out there.
Let's have a logo contest, and everyone has to produce a prototype T-shirt.
And logo?
And wear it here next time. And if we've got a Forth logo, then we've got a Forth flag.
It's all in the merchandising.
Yeah. And there's a whole world out there anxious to buy stuff.
Well, Java lobby already got their T-shirts and so forth. That organization is less than a year old. 2 years old.
You need to aim at 4th and 5th graders by choking on those.
Absolutely.
Put something with Jedi on it. You got it.
Tell them, open the envelope.
Real questions? I do have several talks full of questions backed up,
Say something about
but I won't have time to do it here. One had to do with, I did have another thought. Advantages of Forth in a team programming environment. We've spoken of the fact that a small group of Forth programmers can do an application that otherwise would take many more, and that there's efficiencies of inverse scale at work here. So it's a good team approach. There's another advantage that I haven't heard mentioned. They can do it faster. Time is often a concern in getting applications. And if you want to minimize the time required to do an application, move on a team of Forth experts. Hopefully they have Forth on your platform already. Blitz the problem working 12 hours a day for 2 weeks and go off with it finished. This is a model of a programming, custom programming model, which Forth Inc. is used very effectively and could be applied in a much wider range. when you're working for a company doing an application, it tends to become a career. And heaven forbid you finish the application, you're hanging on a loose end of a loose limb. And that is again, a cultural motivation. It may not be the way the world ought to work, but it's the way the world does work. Moving in a team of, what do you call them? Yeah.
Commandos, software commandos.
Right. Let's have a fourth command. Depends on your rank.
Well, the question I wanted to ask, I had a conversation with a friend of mine, and we were talking about how messed up the world was, and what, simplicity and efficiency, and how people were doing things all wrong, at least I was. And he said, well, have you ever stopped and considered that maybe efficiency has no value, or simplicity has no value? In the grades, he said, look at an apple tree. He says, how efficient is it? He says, society isn't very efficient, but they muddle through. And he says, maybe your expectations of the world are much higher, or really against the natural order of things. Do you have any thoughts on that?
Yes, I agree that economic motives are important, but they're not the only motives. And there are issues of personal satisfaction which ought to be at least as important as the economic value of what you're doing. I like to, this code I showed you, I worked on it 2 or 3 times as long as I ought to have in order to get it right. And I'm never going to execute it often enough to ever get a payback from that. But it feels good. And that's important, especially in the increasingly corporate-oriented world where people go to work to earn a living instead of getting any satisfaction out of it. I don't know that we should be satisfied with a world full of mediocre programmers. Increasingly, if the world, if a culture is depending upon computers in an important way, as Y2K is pointing out, perhaps there's room for some professionals to do it right. I don't know how you sell that.
Especially the worst people.
Sell it to them or value to them?
Yeah, I don't think you can sell it to them. You just don't appreciate what they're getting.
I think the answer to the Y2K problem is not the patches that they're doing now. I gather what they're doing is windowing it, so you're going to have another problem in 2050. But the answer is to make especially embedded microprocessors self-documenting. So you can walk up to one and ask it, what is your take on this particular problem we just discovered 10 years ago? And the way you do that is they store source code instead of binary. And the way you do that is you code it in Forth and compile it at runtime. And then you know that the program that you're running is the program that the source described and that it works the way you expect it to. Especially when you're going to look at that program 50 years from now for the first time and try to figure out what it does. I think that if Y2K comes out badly, there's going to be regulations as to what you can do.
A line of code of life.
We'll just have to get political influence to mandate for it.
I think our fellow primates have a far better understanding of simplicity than we do, in that they have never needed computers nor software, nor do they have to worry about those Y2K or other stuff.
No, that opens it up another conversation. Unfortunately, this margin is too small.
Well, sort of in the pattern of the typist guys in Galaxy, he was saying that they're one of the government mandate that things be done in the proper way. Well, it's already happened. Well, he knows. And I guess that's why nobody worries about Y2K, because,
I I hear that ever since they demandated Ada, it's more popular than ever.
Probably Europe.
Oh, that's an outlook.
But the pressure is going to be on compactors. Because you don't want to store any more in on chip onboard ROM than you have to.
Let us give thanks, gentlemen. And my thanks to you all for coming. It's about this time usually that I say, please buy more coffee and donuts, except that we're over the $50 mark. Thank you all for your generous contributions, even in the absence of a price list. Come back soon. We'll do this again in 4 or so weeks. Dr. Ting, you want to?
Well, I think I would suggest that,